Good evening, everyone. Welcome to LSO St. Luke's. My name is Christine Goodfellow. I'm the Academic Program Manager at Gresham College, and it's delightful to see the hall so busy today. Few housekeeping, just as a repeat, there are 3 emergency exits. If there's anything, please make your way to the emergency exits. After the lecture, we'll have a Q&A for people in the hall, but also for people who are watching us online. I know we've got a large international audience as well, so welcome online if you watch us online. We have 2 options in the hall. You can either scan the QR code, which is on the program, at the front of your program, and then the questions will turn up here on the tablet. Or you can raise your hands, and my lovely colleague Jeff will race to you with a microphone, so everyone, also the online audience, can hear you. If you are watching us online, you can scan the QR code on the bottom right corner of your screen. And again, I'm going to try to keep the questions fairly balanced between questions from the hall and questions online. It's my great pleasure to welcome back our Gresham Professor of Music, Professor Milton Mermikides. Milton is Professor of Music at the University of Surrey. He's a Professor of Guitar at the Royal College of Music. He's the Deputy Director of the International Guitar Research Centre, and he's also an Ableton certified trainer and the Vice Chair of Governors at Addison Primary School, a state school which foregrounds music education, offering free instrumental lessons for all on pupil premium. We're in the 3rd of the series. The series topic is the music of nature. First one was music of animals. If you haven't seen it, please do, especially now with spring. Bird song outside, you want to make sure that you catch up on that lecture. It's online on our website. The second lecture was on the music of light and color, and tonight is all about the music of earth and space, in which Milton explores the deep connection between music and the cosmos. So please help me welcome Professor Milton Mermikides.
Thank you very much. Thank you so much, wherever you're joining me from in the universe. So tonight I'm talking about the connection between the music and the cosmos. And musicians have always been inspired by the world around them. To distort Shakespeare, there is more music in heaven and earth than is dreamt of in our imaginations. But further, there's this ancient idea that keeps recurring that music is not just inspired by the cosmos, but is contained within it. Take the ancient Vedic tradition of Nada Brahma, which means the universe is sound. It's the idea that there's this eternal resonance should we choose to listen. And when we chant Om along with it, we're connecting with that power. And creation itself has this beautiful concept of the unstruck sound, a sound with no beginning. Similar thing happens in ancient Chinese philosophy, this wonderful parable of a master zither player who could play whatever he wanted to. Yet one day he chooses to abandon music altogether because he realizes that whatever he plays is neglecting some other sound. And it's only when he relinquishes his playing, when he listens to nature, that he achieves pure virtuosity. The metaphor is of carpentry. Whatever we fashion from wood is always going to be a reduction, a diminishment of the tree. And so too, human music is a carving of this music of nature. And in ancient Greece, Pythagoras found this connection between number, the cosmos, and our inner souls. For example, if we take a string and we use rational divisions of it, it pleases our souls as well as our mathematical sensibilities. It's as if the cosmos, music, and us are all governed by the same laws, some kind of universal music or a music of the spheres. And this isn't just metaphysical. I could take any musical form and we could see that connection. Take the nomadic tribes of Tuvan, south of Russia, and they've developed this technique called throat singing, which uses, like Pythagoras, rational divisions, not of a string, but of their throat. So what you'll hear now is one human singing a drone, and then emerging from the cosmos are these notes from these divisions. Prime numbers are your juicy. And so Tuvan throat singers are able to basically harmonize with themselves. And they can only use the notes that emerge out of the cosmos, but in so doing, it's really beautiful. Now, if you haven't heard this before, it might be quite surprising, but you may recognize a Celtic edge because bagpipes do the same thing. These are the harmonic resonances coming up. You can see them in the spectrum around here. And they use this not just to make music, but also to somehow connect with nature. There's this one technique which imitates the babbling of a brook, and you can hear the spectrum of the water and of the singer become fused as he bubbles along with that sound. Dissolving into that sound. The Japanese shakuhachi, a bamboo flute, can play notes, but its real artistry is on these gestures which imitate nature, winds, the squawk of birds, the rustle of leaves. Here's these elaborate fingering diagrams to achieve this gorgeous sonic texture. To wait for that one. And we all have these moments in our lives, perhaps we're sitting by the sea or under the stars, where the sound of nature is enough, is a music. Mine happens thanks to my late father, who was a nuclear physicist at CERN, and to whom I dedicate this lecture, where he showed me this muon detector, which clicked every time this interstellar traveler of a cosmic ray shed its subparticle load. And because of Einsteinian time dilation, it made it just enough so it would click in front of me to create this rhythm. And when that muon clicked, there's something clicked in my mind about the cosmos and music. Because sound is a form of communication. This is the longest continuous civilization on Earth. It's lasted for 65,000 years. The Australian Aboriginals. And their civilization has lasted without written text, without recording. So how do you keep culture? Well, through sound and passing them on to others. And the best way to pass something on is through story, through poetry and music. So that their heritage is cradled by memory and the airwaves alone. Now, it's a vast continent. Our maps distort its size. Look how Europe comfortably fits in there. And so what they've built is a network that are called songlines, where they transmit their stories around. And not only do they transmit their stories, but they transmit their maps. Some say that they transmit pathways, navigational charts, in the melodies themselves. So this might identify a mountain range. So if you know the melody, you know what to look out for.
Tabe agona mandara pola nei tabe agona mandara pola nei tabe agona mandara pola nei.
But sound is not this passive canvas which we write music upon. It's this active force which actually influences the music that we make. Take the Baka pygmies the Baka people of the Congo region who have developed this vocal technique known as, appropriately, as yelly. It's being created to cut through the dense forestry and call animals for a hunt. And now it's become this beautiful heterophonic tapestry. Or the cathedral, whose immense space creates reverberations which demand music that works when harmonies overlap and have soft transients, but in return it transforms four voices to a divine choir. Or the salon, whose clear acoustic invites, obliges detail and character. Or the cobbled streets in Spain, where flamenco has learnt to cut through that dense air and use those echoes and the rasgueados, palmas, and the heel clicks. And take a box, pump it with loud sound, and you can turn otherwise civilized people into a sea of licks. Fuck you, I won't do what you tell me! Fuck you, I won't do what you tell me! Fuck you, I won't do what you tell me! Gresham College, though. Fuck you, I won't do what you tell me! And what's extraordinary now is that we don't actually have to go to those places to experience those sound environments. We have something called impulse responses or convolution reverb, where we can collect that sound and use it. So at our disposal, we have every space on Earth. And some colleagues of mine traveled to Cairo just last year to collect not ancient artifacts or memories, but the sounds inside the pyramid of the king and the queen's chamber. A forbidden space which we now have access to. So this allows me to take a replica of an ancient Egyptian lyre and put it in that space, so together we can experience that forbidden resonance. Now, when I speak to you in this room, each word lasts about a second in resonance and travels 100 meters or so. But sound behaves wholly different in the ocean. Go down a kilometer, and one sound can last the length of an album and travel literally thousands of miles. And whales have learnt to dive down to that channel, it's called the SOFAR channel, to communicate. We used it in the Second World War to rescue downed aircrew, but whales used it long before, creating song lines of their own. And there's something about water which has a musical quality, the way it changes, but I think it's because it wears its waves on its surface. We can actually see the waves. It inspires music, but it's also used to make music. And again, around the world, we have this recurring idea that the music can be made from water. Here's some women in the South Pacific who have developed this bonding ritual with girls and women. It looks super fun, but I guess I'm not invited. And then on the literal other side of the world, we have the Bayaka children of the Congo region making this extraordinary rhythmic musical game. I've transcribed it here for you. It's as if there's music flowing through this water. And there are so many examples. I was going to do a whole list of them, but I would take too long. But I'm going to just pick one, which is Rachmaninoff's Isle of the Dead, a symphonic poem inspired by a painting you see here of the same name. And if you listen to it, there's something watery about it, even if you don't know its influence. You might notice its lopsided rhythm. It has a 2-3 rhythm. And that's the same pattern we see in rowing. You pull for longer than you release, and actually in the shape of waves, which aren't sinusoidal, but skew to one side. So Rachmaninoff is intuitive of this. Sometimes they change direction. It's beautiful. I'm just going to show you a little bit of the piece, and I've superimposed the actual notes, and you can see the waveforms as they build. Splashes of foam at the top. It's so beautiful. So these is made up of little waves, but what's really beautiful, and I discovered this, if you zoom out, those little waves become one huge tsunami of music. Look at the shape of it. Now we think of nature and music as separate, but this is a musical performance by a choir who used no instruments or voices, just snapping fingers and rubbing hands to create, quite uncannily, rain. You can join in if you like. It's remarkably effective, but some sporadic clicks will do, some hand rubbing. I mean, I can't tell the difference. It's not pre-recorded, it's pure choir. We'll wait for the thunder, which is astonishing from a jump together. What's extraordinary about music, though, is that it can imitate sounds, like an onomatopoeia way of connecting, but it also can evoke the feeling of being in that situation. So it walks that line between imitation of nature and evoking feeling, somewhere between sound and feel. And Beethoven does that in his Storm, or from Symphony No. 6. This is how he creates what I hear as heavy rain. He has groups of 4 in the bass, and then quite progressively groups of 5 in the cellos. Now, if you heard the piece, you wouldn't hear it, but you'd feel it. It's this watery interference pattern that happens, that even in MIDI is really effective. It's a masterful stroke of imitation and evocation. And here's his lightning. I love his handwritten scores. I'll never complain to students again. But look at the shape, how this is his lightning bolt on the right, and see how angrily he's lashed out on the page for it. So let's hear a little of the scene when lightning and thunder comes, and I've superimposed his handwriting on top of it. Now, you notice that they became more frequent, those lightning bolts. But I also noticed that the gaps between the lightning and the thunder change. Now, that happens when the storm is at a distance. And you'll see here that when there's a longer distance, the thunder is quieter, which is correct. And it gets progressively louder as it gets closer. Now, if you're a massive nerd, you can thereby calculate the distance of Beethoven's storm, given the crotchets and the tempo. So at 7 beats at 190 ppm, we have a storm distance at a safe 758 meters and dynamic of p. Wait, and there it is. Then it gets progressively closer, and you'll see the dynamics increase. That's 325 meters. However, when it's just 1 beat apart, we're at 108 meters away, which becomes in danger of the wrong type of conducting. And so climate inspires music, but now there's this art where it can actually dictate music. This is, on the top left, John Luther Adams' piece, where you can listen to the climate data in one position. And superimposed is my 4 warnings for piano, where simply temperature, CO2 level, and sea level are given a voice, and you have a counterpoint of ice mass. You can argue politics, but not melody direction. And there are waves all around us and underneath us. It turns out the Earth is as unstable as the sea. And if you choose to listen, for example, with this Earth Tunes app on the right, you can just navigate the globe and listen to live seismic data. Scoot it up a few octaves and you can have a lovely afternoon. On the left is a time lapse of seismic activity in Iceland. So the planet is resonating with these sounds, but it also forges other waves, like this beautiful mountain range in Brazil. Look at these lovely waveforms. Now, the music you're listening to is by a Brazilian composer known as Villa-Lobos. If you're a guitarist, you will know the name. He was an astonishing composer who contributed so much to the repertoire of his instruments, the guitar and the cello, wrote amazing symphonic works, and heightened Brazilian art music, the single most significant creative figure in 20th century Brazilian art music. He was so good you might say he was on the money. By which I mean, this is my dad joke for the evening, he is on the money. In fact, these were discontinued sadly in 1987, but eBay, everybody. I've bought them all, don't check. And amongst his huge archive of writings and cigar boxes, we find some odd notations, these strange shapes in his artifacts. What could they mean? Well, let's take one of his pieces, Melodia de Montanha, which I think you can translate. And it's got a location beneath it. And I was interested to know what this was, so I hunted it on the Google Earth. And this is the range of piety, it's called, viewed from Belo Horizonte. Here's another beautiful picture of it. Isn't it lovely? And amongst his artifacts, we find this graph. What's he doing? Well, it turns out that piece is an exact carving of the top line of that mountain. Isn't that beautiful? So using his Bach and jazz skills, he's able to harmonize it beautifully. I'm going to have to wait for my favorite chord. Wait. Thank you. see it carved on graph paper, which became score, which was ultimately sourced from this mountain. But there are many mountains in Brazil, like this finger of God, it's called. Sounds painful. And you'll see in his artwork these photographs and also this graph paper. How well do they match? Exactly. And Villa-Lobos used to enjoy being by the mountains, transcribing the skylines to use as themes. Sometimes he did the shape of his friends, but he complained that they were the wrong shape. Bit rude. So he collected all these themes, most notably in his Sixth Symphony, suitably named on the outline of the mountains of Brazil, where he collated lots of these mountains and lays them bare to be heard. Now, still there's orchestration and beautiful arrangement and harmonic skill, but he presents them really factually, and I'm going to show you a part of the piece, and I've done my best to hunt down the mountains and try and lay them next to each other. But of course, there are these skylines all over the Earth. And thanks for a neuroscientist's spare time, we now have Earth sounds XYZ, where you can hunt down these profiles, turn them into audio waves, histograms. You can even take the path of water and access these sounds yourself. Or perhaps take your favorite journey and turn it into a melody or a tone. There's some shortcuts for you. But there are more skylines around us that we've built. Here's New York in the mid-20th century. And yes, among Villa-Lobos' work, we see the New York skyline melody. He did something a little more this time. Not only did he do a top-line tracing to create this beautiful chromatic melody. It's got a nice repeating motif here. But also the foregrounded voices, so we get polyphony. So with his harmonic skill, he's able to craft a piece that I find beautiful in its own right. And because I know the piece so well, I actually know the New York skyline of the 1930s very well. It's not that useful, but... impressive. What's lovely is architectural style becomes musical style. We have a motif in the midline, which is repeated on the ground level. And of course, there are many architectural styles that we could source for such musical gain. Goethe said that music is like liquid architecture, buildings that move, and conversely, architecture is a sort of frozen music. My project, Liquid Skylines, builds tools so everybody can have melodies from their hometown or their favorite places on Earth. But musicians return the favor. Here's a sculpture of 4 bars of a Bach fugue. It outlines the melody, but you can actually walk through it and enjoy the voices, touch them even. It's only 4 bars, just a fragment. Let me help you out. That's all you get. I think we need the whole city, really. But music has its own architecture. Everything from Puerto Rican folk to Scott Joplin to classical music has strong and weak beats. This is the population of notes in those positions. And you can see that to have rhythmic grids, we need strength points that can support others. And pieces, compositions, are like architectural worlds that we walk through. Top left is Pachelbel's canon. It's like 3 travelers walking through that same landscape. Bottom right is one of Bach's riddle canons. Top right is Schubert's harmonic moves on a donut, and on the bottom left is the 22 Shruti of Hindustani music on a circle. And composers like my predecessor Xenakis can even build strange architectural worlds to walk through, laying out parameters and exploring them. I like it. It's as if both music and the physical universe obey similar laws. Reich's pendulum music and algorithms are understandable off the grid of music notation. And this device on the bottom left uses gravitational laws to create musical material. So our whole planet is chiming with resonances. The aurora dancing off the atmosphere can be scaled down to sound. And actually the Earth has its own harmonic series, but because it's not a string, it's a sphere, it has these what's called spherical harmonics, which sound like this. Which actually contains an even-tempered tritone. There's something natural there. Time for space. Sound doesn't travel well in space at all, so we have to use alternative means. We can load up music on the space probe and send it out, hopefully to be discovered by aliens. However, it's only traveled 1 light day, which is nothing in the universe. Our radio bubble, our sonic history of broadcasts, is 100 light years, but that too is peanuts when it's compared to our galaxy, which is peanuts again. Is space completely silent? Well, it turns out that in our short time of space exploration, we have found 3 places other than Earth where we've got some decent sound. One of them is our nearest neighbor, Venus. This is actual footage from the surface of Venus by a Russian space probe, and actual sound. Quite astonishing, really. And that graph on the right shows that on Venus, high frequencies are masked a lot more. So while on Earth, we listen to Holst like this. On Venus, it would sound more like this. It's good for techno. Where else is there sound but on the moon of Saturn called Titan? Best view in the galaxy, I think. And again, we have footage and sound from Titan. Now, we assume that sound on Earth is the perfect ideal, but you can see from the graph that there's better acoustics on Titan than there is on Earth. So that's where we should be doing our recitals. LSO's Titan. Let's just land our spacecraft, if you don't mind. Gets me every time. But where we have the most data, thanks to this little fellow, is the surface of Mars. These are images and sounds taken by the robot explorer Opportunity, who spent 14 years in service for our curiosity. Sadly, a dust storm wiped him out, so he was unable to recharge his solar batteries. And the last message he sent us was, "My battery is low and it's getting dark." Why is that so sad? It's metal. Yet, sound on Mars is really interesting. Yes, the high frequencies are damped, but they're actually slowed down as well. So on Earth, Mars, the piece, sounds like this. But on Mars, the low frequencies are delayed, so you get these zaps really appropriately. So now we have Mars verb to add to the list of sounds. So when we do our concerts on Mars, either we have to put the violins really far back to balance, or we have to put everything through inverse Mars verb. So it sounds normal. But because space is generally silent, we've had to represent its music. And composers have used various tactics. One of them is to imagine music of space being devoid of some culture or physical environment. So we use pure frequency and abstracted sound, like the early electronic music of B-movies or Theremin here playing his namesake. But what we can do is imagine a parallel world where the styles are mixed up. So let's just imagine all the instruments that don't belong together and put them together, like a synth bass, and then maybe 30s swing jazz groove. And then what else? Caribbean steel drum and a brass band, perhaps. And that's what John Williams did for Star Wars. In fact, he was asked to imagine that aliens had discovered our record collection or our radio bubble and didn't understand it completely and just made their own music from it. Music is also used in these media as a way of communicating intelligence. How do you communicate intelligence without a shared language? And one way is to communicate low entropy items, things that couldn't arise naturally. And that would be numbers like the harmonic series. So it turns out a lot of the themes for sci-fi movies can be played with the harmonic series. This is a throat singer playing the Close Encounters theme. Or the theme from 2001 is just a walk up the harmonic series. Or we can imagine that they have an entirely different music theory. They don't build chords and triads, but seconds, and spread motifs over minutes, not just a phrase. Ironically, Ligeti was channeling Renaissance music here, but there's a sort of shared ancient logic, perhaps. But the most resilient way of eliciting the sense of spatial distance is through harmonic distance. What I mean by that is that some notes feel closer together than others. And I don't mean on the piano, because when you go to a piano and you play the two closest notes, they sound distant musically. In fact, if you take a note and you bring out its fifths relationship, they feel closer than any other. Thirds feel close also. So we can actually map out all our notes in these spaces, a circle of fifths, or if you're fancy, a fifths and thirds. And earthly music tends to create chains of these fifths to make these sorts of shapes. But if we want to evoke space, we break those chains. And so we find space music does this. In Holst's Mars, we have this tritone relationship, getting as far away from the initial note as possible. Take our ordinary triads and move them not in common ways, but in sort of twisted harmonic shifts, like a G minor and an E flat minor. They're kind of close but far. They break the diatonic boundary. And so we could build melodies around that twisted space-time fabric. Or the idea of wormholes in space, where you have one chord and another, and you sort of pass through them. Here we've got A minor and C sharp minor at the same time. This creates a sort of sense of portal-like motion. We can create a sense of uplift. C to E minor feels close, but if we go C to E major, there's a sort of float there. And this is what happens in Space Oddity. When he's on the ground, he goes C to E minor, and then after takeoff, which makes it feel a little lonelier. But maximal distance is taking two triads and putting them a whole tritone away. F, B, F. Even at the same time. It's like we're transversing harmonic space at warp speed. So harmony has become this language whereby we transverse space in these epic journeys. extraordinary how just notes can bring us to different places. Take the chain of fifths that make up the diatonic scale. They feel happy, but grounded because of all 5 notes are ascending the fifths and 1 is descending, and it kind of keeps a foot on the ground. It's happy, but it's grounded. And what happens if we let go of the ground, just go fifths all the way up? Suddenly, we're in microgravity. But let's move beyond being inspired by space into actually translating it into music. Now, you see these diagrams from astronomers who like to use the metaphors of music, but what could it mean? Well, I'll tell you specifically. We find examples of the ideas of planets as fretboard markers. So imagine we have our solar system and we attach a string to the sun and one to Neptune. Don't ask me how. And there's distance to us, like on a Pythagorean instrument, would be at certain intervals. What would it produce? Something like this. Quite nice. Or we can imagine that how planets move creates music. And this on the top right is not some metaphysical diagram, but an exact representation of Kepler, who was the first to define elliptical orbits. Now, elliptical orbits have different squashiness, eccentricities they're called, and he represented them in terms of scales using Tycho Brahe's data. I love the moustache. I'm working on it. How close did he come? Well, it's astonishing, which is testament to the data and the science of 1609. He's within a semitone of every single one, which is as close as you can get to on the stave, because we don't have split notes. He's actually 1 semitone out, but we'll forgive him on Moon. I'll give you an example of how close he is. This is how he represents Saturn's motion. But as a sine wave, it would be... It's almost exact. He got this one a little wrong, but I want to note that the Moon moves in a perfect, just intonated major third. Perfect. But the most resilient approach to translating planets into music is to think of them as oscillators. Imagine we're orbiting the sun every year. You don't have to imagine. We are. And if you speed it up, it will happen every month, and then every day, then every hour, then every second. And we've entered the rhythmic domain. So what happens if we speed up the solar system? Well, Mercury would appear, some 37 octaves, as our fast and high rhythm. Then we'd have Venus, slower and a little lower. And they make a pattern between them. Then us. And then my favorite, Mars. They collect up into this lovely rhythm and chord. And I haven't fudged the rhythms or the pitches. This is the solar scale. It doesn't match the piano exactly. It sounds a bit janky. But we do have 2 C sharps, 2 G sharps. In fact, it's a D major 7 over G sharp. Is that a fluke? Well, we started to hunt out different planets. This is TRAPPIST-1, which has 7 Earth-sized rocky planets. And it produces something we can generously call harmonic ratios. It might take some acquired listening, but like anything, there's beauty in every relationship. We can even find octave relationships. 3 of Jupiter's moons are in a 1, 2 to 4 relationship, creating a cosmic countdown theme. Now, maybe we shouldn't be so impressed because that's 3 of 95 moons. Any reason for harmony to exist in the cosmos? Well, this is K2138. It's the first major discovery by citizens like you and me through Chris Lintot's, our professor of astronomy's Zooniverse project. And this is its chord. Pretty. Why is it pretty? Well, they are in 3-2 relationships, 3 over 2. They are Pythagorean fifths. Pythagoras would be happy. So they're resonating like this. Why? Well, the leading hypothesis is that harmonic relationships meet often, so they clear debris, and so they stabilize the system. Music is used as a mechanism to create order from chaos. They've discovered a 6th planet, which isn't the 5th, which has annoyed everybody. And waveforms and data are found throughout. This is X-ray radiation from a massive black hole in the center of our galaxy. The patterns of that radiation turn into sound. It's the heaviest music you can imagine. And pulsars are stars that have collapsed to the size of London, and they start spinning at the rate of twice a second up to 700 times a second, which is perfect for rhythm and pitch. This is Andy Dayton's pulsar sonification, where you can play the universe if you're at a loose end. But I'd like to end this lecture at the beginning. In 1964, 2 engineers from Bell Labs noticed by accident that there was this constant, faint radiation everywhere, wherever they checked. They checked their equipment, but there was this constant, persistent resonance. And it turns out it was radiation from the Big Bang. What happened early on in the early universe is the space wasn't transparent, it was opaque. It was like a plasma source. So sound existed at that time. At the time, they really could hear you scream. And so we have these sound waves, and then they became transparent, and we get light emerging from it. But the sound is there on this map, frozen in time. And what you're looking at is the earliest sound, or at least the remnants from it. It's quite extraordinary, isn't it? So in 2011, they've managed to sonify it so we can listen to that ancient sound. And isn't it extraordinary that we live in an age where we can tune into that original unstruck sound? Thank you so much. Thank you. Thank you.
machine and I could put you, Tycho Brahe, and Johannes Kepler in one room, not to discuss music or space, but to discuss how you visualize your data.
Okay, I'm free on next Thursday.
So we've got a little bit of time for questions. If you would like to ask a question in the hall, my colleague Jeff will bring you the microphone. Jeff, can we maybe start with a lady there who's literally not drowning but waving? If you could keep the questions short so we can squeeze in as many as possible.
Hi, thank you so much. So, short question. The Dutch mathematician called Hans Kuster, he wrote a book called The Octave. Well, anyhow, he calculated the frequencies of the planet in hertz. Have you heard of it? What's your opinion about
That's what I've done there with those orbital resonances. So basically, just to clarify what's happening here, we hear from about 20 hertz to 20 kilohertz. Yeah, not me anymore, but from 20 hertz. So if we scale up octaves, then we can hear any frequency, or at least we can turn a frequency into the sound wave. What you heard with that planetary scale was exactly that. Actually, people cheat a bit because the range of the solar system extends in octaves wider than our hearing, so they crush in the octaves that way. But other forms, like as fret markers, that is 6 octaves, and we can hear it nicely. Well, it's correct that if you change frequencies, you can hear them. Now, the question is, what does that mean? Because we can turn anything into music, and I generally do. And the question is why. I mean, it's enjoyable and fun, but it's interesting when it matters. For example, the mountains, their shape is forged because of some reason, and we can sense it, and there is some sort of meta-language that is going on there. And for example, with that last planetary system, they are in fifths because they survive that way, and that's fascinating, I think. So yes, it's true, we can do anything, and then it's a question of what does that mean?
I love it when people kind of self-censor their questions. So are you ready for a silly question?
Yeah, I want the silliest one you have there.
So Shane says, silly question. Close encounters of the third kind, 5 notes, used to communicate. Your thoughts on such a simplistic but deep conveyance of communication?
Yeah, it's brilliant. Actually, so what's amazing with music that we don't sort of fully acknowledge is that imagine you see someone that you haven't seen for a long time, you recognize their face. Their face has changed, it's a different angle, it's different light, but somehow we know its coordinates. And we have exactly the same when it comes to music. So you can recognize a melody played on a different instrument at a different speed, at a different pitch, usually. Why? And it's because it has a geometric pattern, a relativistic geometric pattern that fits in our brains somehow. So there's also this idea that if we send a signal, how would we send a signal that we want it understood as intelligent? And that would be one way to do it, because with close encounters, as they say in the film, it's a bunch of intervals, and some of those intervals are repeated. So it's not just a sequence of sounds, but it's a grid that is inferred from those relationships. And that, I think, is a sort of high level of intelligence.
So not a silly question.
No, that was
right?
Do better or
any
worse.
More questions from the hall? No more hands up. Oh, yeah, there's one. 1 second, Jeff's coming. 1 second, yeah.
No, just a quick one. I saw that you had a picture of Mahler there, but I don't remember hearing anything that you've played from him.
Mahler, was it a collection of music representations of space?
Yes.
So we had Holst,
yes.
Planets, we had Ligeti, we had Louis and Bevy Barron, the husband and wife team who wrote the first fully electronic score for Forbidden Planet with Leslie Nielsen. I need to get out more. What else did we have? And I can't remember if Mahler was there. I don't know if he was. We can discuss it later, but it wasn't meant to be. So.
I love this one, from Anonymous. Do you think Debussy deliberately continued the bass wave formation in Clair de Lune skywards to point towards the moon, which creates waves on Earth?
That's so beautiful.
Right, huh?
I don't know. It's really gorgeous. But I've used Clair de Lune before because he does this gorgeous thing where he's using the bright ascending fifths, and then he drifts into there like the dark side of the moon. But I've not sort of thought of tide formations, but it's totally beautiful. And that's the subject of my next lecture.
Any more questions from the hall? Yep. 1 second. I can just, while Jeff is walking up there.
Yeah, give me another online one.
One online? No. I don't have a question, but this is great. Thanks, Joe.
Okay. Thank you.
Right, okay.
Thank you. That was a really great talk. I really enjoyed that. I'm curious, what's your favorite sounds in nature or your favorite music from nature? Music
in nature. My favorite sounds, well, in the music for animals, I have an affinity, of course, to the Mediterranean. And they're annoying, but they're cicada, I don't know how you call it here, and waveforms and rusticities, that sort of combination. And then throw in a Scops owl, metronomic hoots, and I'm happy.
Any more questions in the hall? We can squeeze one more in. No? Okay. Well, we'll just have one on opinion. Do you want to give your opinion on something?
I hate cheese.
From Prashant. What's your opinion on the Dune movie soundtrack? It sounds very outer space to me and also involves the throat singers for the Harkonnens. Sorry if I mispronounced this.
Dune.
The Hans Zimmer one.
Oh, I don't know the Hans Zimmer one so much. It's good. I mean, I love the Toto original theme. It's just the perfect, it's like they've got all the perfect ingredients for space music and they use it exactly the right way. So it's great. You know, Hans Zimmer does, I'm being recorded, so I'm going to be, he does some amazingly proficient stuff. I like to be surprised, though, and there was a movie called Moon, I think, Clint Mansell, the composer, and it was just generally solo piano music, and there was something extraordinarily bleak and beautiful about that. So I'm sure it's great, but I showed you sort of the tropes, which I love, but I think it's really fascinating when we get surprised, which humans are still able to do, I think.
Thank you very much. We've got maybe one more thing to say. So next lecture is 2 months away, 15th
Wednesday,
of April.
Wednesday, 15th of April in this hall, Music of the Mind. This is your brain on music, essentially.
Not mine, but...
This is your brain on music.
Thank you very much for coming, and thanks again, Milton.
Thank you so much.